Hi there, this is Penelope. This is a video on the singularity of a matrix. Now, the definition is that a square matrix is singular if and only if, it's not a typo there, if and only if its determinant is equal to 0. So conversely, if the determinant of a square matrix is not equal to 0, then the matrix is said to be non-singular. Now, we use the determinant a lot to find if the matrix is invertible, because if the determinant is not equal to 0, then we can find the inverse. And remember, we call the inverse a to the power of -1. We use the inverse to solve systems of simultaneous equations. So it's good to know before we start that the inverse can be found. Let's have a look at a simple one. This is a square one where it's really easy to find the determinant. So if the inverse exists, we will find that the determinant is not 0. So let's find the determinant. It will be 2 times 9 minus 5 times 1, which is equal to 13. So the matrix is invertible. So we could find the inverse if we wanted to. The second example in this video is asking you to find the values of lambda that make the inverse not exist. In other words, that make it singular. Okay, so let's find the determinant of a. So it would be 5 minus lambda times -2 minus lambda minus 6 times -1. And we need to find out whether or not that is equal to 0. If the inverse doesn't exist, then it will be 0. And that's what we're looking for, the values of lambda that would make it 0. Okay, so if we expanded that, we would end with lambda squared minus 3 lambda minus 4 is equal to 0. That's easy to factorize. So we can find that lambda equals 4 or lambda equals -1. And if we put both of those into a, we would get that a was equal to 1, -1, 6, -6, or a is equal to 6, -1, 6, -1. And the determinant of both of these is equal to 0. So it doesn't have an inverse. It doesn't have an inverse. So a doesn't have an inverse if lambda equals 4 or -1.